Okay, so we type in y equals sine of x. Do you see the little wheel, or some people think it looks like a flower? Do you see it? Okay, you're going to click on that. Okay, that's like the settings wheel. And then you're going to click on the icon that looks like a table. Desmos will create a table for you from your graph. The catch is that these aren't the x values that we need. So what we're going to do is we're going to change those x values to be what we need. Ooh. Just a second.
That's cool.
Okay. All right, so I'm going to go here. I need this crap. Okay, we're good. So if you look at the x values that we need them in terms of pi. What's cool about Desmos is that it will let you type in pi. So in this first one, I need -2 pi. Yes?
Yeah.
Okay. If you just type pi, the letters pi,
Oh, wow.
it'll change it to pi for you. Okay, it'll change it to pi for you. So we're going to go ahead and change all of the x values that we need here. So change all of those x values to be the table that is on your paper.
Yes.
So if you just use pi for pi, Desmos will automatically change it for you. Oops, I needed that to be 0.
What'd you say?
Okay? You doing this today is going to help us later in the week when we do transformations, because we're going to use Desmos. So this is really, really nice. Okay. Once you have that table filled in, you can go ahead and graph. The deal with graphing is that you have to mark where your 1 and -1 are at for your y-axis. So go ahead and do that first, and then you can plot your points and draw your graph.
Okay.
Wrong. Once you have that table filled in, go ahead and plot those points on your graph. You should be able to draw that curve.
Pretty sure. Right.
Using that table, plot your points.
Oh, yes. Yeah. Oops. Almost forgot so.
Okay, so first question before we start answering questions about the graph. What do you notice about this graph? Does it keep going? Take a look at this, folks.
Yeah.
It does, right? So I want you to go ahead and you can kind of do a little dotted line to show that this is going to continue on. Okay, put some arrows there at the end. So when we talk about domain of a function, it's associated with which values? x values. So our x values, are they going to end? No, because this graph just keeps going on both ends. So we can say negative infinity to infinity, or you can do the double stick R, which means what? All real numbers. So you can do negative infinity to infinity, or you can do the double stick R to show all real numbers. Yes, range would be, what'd you say? Negative 1 to 1 for your range. So if you look at your y values, they go from negative 1 to 1 on that y-axis. So negative 1 to 1 there. Now you'll notice I put lines under my inequality symbols in my set notation. That shows that it can be equal to negative 1 and 1. Okay. Okay, tell me what you notice about our x-intercepts. Say it again. It's like pi, right? It's like 0, and then pi, 2 pi, yes? Okay, so could you agree that if we take a number k, okay, just a number k, a whole number k, we could write the rule that the x-intercepts are k times pi, like 1 pi, 2 pi, 3 pi. Do you agree? Okay. It could be negative 2, negative 1 pi. Okay, what's our y-intercept of our graph? 0, 0. It crosses the origin. 0, 0. Okay, our maximum values. Okay, now maximum is a y value. Okay, so we can all agree the maximum for our graphs is 1, right?
Yeah.
But let's talk about the x values where they occur. They occur at pi over 2, negative 3 pi over 2. Where's the next one going to be? Anybody have Desmos up? So if I go here, what's after 2 pi? See if you can figure it out. Type in a number, see if that happens.
5 pi over 2.
5 pi over 2? Okay. So, we can make a rule for our maximum values and say, okay, well, we know that they start at pi over 2, and then they add 2k pi each time. So not 2 pi, but 2k pi. So you can add 2 pi, but you can also add other pi's to that. So that's kind of the rule that we use for the maximum. That's not something that you need to memorize, so don't worry about that. It's technical. Okay, so we know for sure on our graph right now, we have pi over 2. What was the negative 1? Negative 3 pi over 2. Those are the two that we visually see. Okay, our minimum value, I believe that it starts at 3 pi over 2. Yep, starts at 3 pi over 2, and then we add 2k pi to that. Again, you don't need to memorize that, it's technical. So on our graph, we have negative pi over 2 and 3 pi over 2. Okay, we're almost done. We'll go a lot faster. Sine is an odd function. Everybody say odd.
Odd.
Okay, it's an odd function. That means that it is mirrored or symmetric over the origin. So if you look at your paper, okay, if we were to flip our graph over the origin, it would be mirrored. Okay? Sine and cosine functions have something called a period. So think about like periods for school, right? Each period is 50 minutes, and then you repeat it. Okay? Kind of an easy way to think about it. Sine has a period of 2 pi. So what that means is that from 0 to 2 pi, everything is new. And then after that, it just repeats itself. Okay? So you can say, which means the graph, I know that you guys can't see that clearly. The graph repeats after 0 to 2 pi. So after 0 to 2 pi, the graph repeats. Okay, cosine will fly by. I already know what we're doing. So I want you to go to Desmos. Okay, you don't need to redo anything, so don't delete it. You're just going to go up here to where sine is at and replace SIN with COS, and it will change everything for you. Easy peasy. So change that to COS, and then you can fill in your new table on the back.
Whoa, that's right.
Okay, and then you can create your graph. Okay, I went ahead and put my arrows on the end of my graph. Okay, what's our domain? Yes, same thing. All real numbers or negative infinity to infinity. It's going to continue on that x-axis. So you can write it either way. Doesn't matter to me. What about our range?
-1 is greater than or equal to -1 is greater than or equal to.
-1 to 1, right? It's just between those two y values. Balances between the two. Oh, I forgot my equals.
Yeah, I was going to say,
Oh. Okay, so for our x and our y intercepts, okay, our x-intercepts are a little different. Where's our first x-intercept at? Just start with the positive version.
Okay.
Pi over 2, right? Do you agree that our first x-intercept is at pi over 2?
Yeah, I guess.
Okay? So then we're going to add 2k pi each time to get to the next one. Okay, what's our y-intercept? Different. Different than 9.
0, 1.
0, 1. If you look at our y-intercept here, okay, it's that 1 up there. Maybe. Okay, our maximum value is still 1 for the y. To write that as x. Oh, guys, I did this wrong.
Oh, no.
Oh, no.
You ruined it.
Maybe hold on, sorry. No, we're fine. Okay, our maximum is 2k pi. So the first one that you see, if we're looking at the positive version, The first maximum you see, not including 0, is at 2 pi. Okay. So we can technically say 0, but also say 2 pi. Okay, our minimum, where's our first minimum? Where's our first minimum? Pi. Okay, so our first minimum is at pi. To get to our next one, we would add 2k pi. I have to use my notes because I get all these stuff in my head.
Yeah, I feel that.
Yeah, do we need to know this?
No, it's just, it's notation. Just don't worry about it.
So looking at the board and mindlessly writing stuff down.
What?
So looking up there,
We're learning.
Yes, for this part, yes, for sure. For sure. Okay, so our minimum values up here are negative pi and positive. Okay, if sine is odd, cosine is even. Okay, it's symmetric about the y-axis. So if you look at your graph, if we were to fold this graph over the y-axis, it would be inverse, okay, or it would be symmetric. Okay, and again, a period of 2 pi, which means as the graph goes, okay, from 0 to 2 pi, it'll just repeat itself after that. Okay.
Right on.
There's one last question at the very bottom that I want you to think about on your own. Look at the front of the page and the back of the page and see if you can pick out the fundamental differences between sine and cosine. Okay, so it can be as simple as looking at the graph and saying the y-intercepts are different, the x-intercepts are different. So pick out those things that are different. That'll help us tomorrow, okay, as we get started tomorrow.